All right, I am working on a fluorescent bulb ballast today for a friend of mine. And as I was looking at this, I was reminded of a conversation I had the other day with a friend who said when he changed the starter on his truck, he was terrified that he'd get electrocuted and die. And I basically told him, well, that's impossible. You can't get electrocuted and die from working on a car. And he said, what are you talking about? I thought there was like 500 amps in the battery and you only need half an amp to kill you and all that kind of stuff. And I was chatting with him about voltage and amperage and all of that. And one of the things that I really enjoy is demystifying things, sort of pulling back the curtain, not to teach a college level class on electricity, but just to remove the fear and to demystify and remove the intimidation of something. And so this is a general layman's video about voltage and amperage and what's dangerous and what's not and why, and just putting a little bit of sense to it. So first thing I want to show, I want to create a analogy. And I read in a book that teachers make things complicated, communicators make things simple. And so I'd like to make electricity relatively simple for you. And to do that, I want you to imagine that electricity is like water flowing in a pipe, okay? So you have voltage, amperage, and wattage as you refer to electricity. And I want you to think of those. Voltage is like pressure, amperage is like volume, and wattage is just those two multiplied by one another. So I want you to imagine scenario one. This is a hot tub, okay? This is a hot tub that you jump in and it's like a jacuzzi. And it's running, but that's just the water analogy, right? So this is like what you have in your car. You have a battery which is at 12 volts. And let's say it has 500 amps. And if you multiply 12 by 500, you get 6,000 watts. Now, I've heard, and I think it's correct, that half an amp can kill you. So the question would be, why is it that anybody can pop the hood on their car and touch the positive battery posts when they're jumping a car or something like that, and no one's dying? And that's because even though there's 500 amps in there, they can't get through your body. Just like jumping into a swimming pool or a hot tub doesn't kill you. And so here's what I want to explain. 12 volts is like pressure. And if somebody squirts you with a squirt gun, it bounces off your body. It doesn't go into your body and cut you in half. But if we think of a different scenario, like your house, which has 120 volts, and 50 amps, you still have the same 6,000 watts that you had over here. But this is different. This is now more like a pressure washer, where you have a lot of water coming through a very small hole at a very high pressure. The water that comes out of this pressure washer nozzle is enough to cut you. And in fact, water jets, which are used in manufacturing processes, have even higher pressures, and they can cut steel and all kinds of things. And it's intuitive for us to realize that the difference between this and a squirt gun is the pressure. What's not intuitive is the difference between a car battery and a house outlet is the voltage. And voltage is basically, another word for voltage is electromotive force. And you may have picked up in life that force and pressure are sort of used interchangeably, although in physics they're different things. But this is the different pressures. And so what you find is that if you're working on a 12 volt system, like a battery, it cannot hurt you. So I have this hooked up to a multimeter over there, which you can see is at 12.6 volts. And I can touch these, no problem. You can touch them with one hand, also no problem. What I can't do is put a piece of metal across here. If I do, all 150 amps are gonna start flowing through that wrench, and we're gonna have major sparks and major arcs. So I would never put that on top. I would lose my wrench and probably burn my hand and destroy the battery. But I can put my hand there all day long. And that's because in electricity, you have conductors and insulators. Conductors are things like metal that conduct electricity, and insulators are things like plastic that don't conduct electricity. And then you may have heard in Silicon Valley, with the age of computers, a term called semiconductor. And that is a material that conducts under some circumstances and not others. And that's what silicon is. That's why it's called Silicon Valley, because at the heart of computers are transistors, and at the heart of transistors is the material silicon. Now, in some sense, your body is a semiconductor, which means at some voltages, at some pressures, your body has enough electrical resistance to impede the flow that would normally travel through this battery. Just like your body has some ability to resist when someone shoots you with a squirt gun, it doesn't cut you in half. But if they get out a really high-end pressure washer, they can cut you. And so when you're working on a system with 12 volts, you don't have to be afraid of getting shocked or electrocuted. Now, you may wonder, at what voltage does it become a problem? And that's a little debated because humidity and moisture and all of those things can play a role. But you see right here, I'm on OSHA.gov. It says, however, OSHA considers all voltages above 50 to be hazardous. And that's actually why you see some things at 48 volts, like telephone lines and even modern day lithium ion batteries for tools are coming out in 48 volt increments, because once you get above that 50 volt threshold, all of a sudden the government wants you to take all kinds of special safety precautions, which are expensive, which increase the cost of goods and services and all of that. And so by keeping it below there, they can keep things less expensive. So this is not meant to be some sort of an electrical course so that you can work on your home or your car or anything like that. It's really just, again, I enjoy demystifying things. I enjoy taking the intimidation factor out of things. And so what I want you to take away from this is that voltage is like pressure. And just like a squirt gun can't hurt you, but a pressure washer can, low voltages cannot make use of your body as a conductor, which means when I do this, no amps flow through my body. If 150 amps were flowing through my body, I would be dead. And you will encounter the word wattage occasionally, and you can understand that wattage is just voltage times amps. And so you can actually sort of reverse engineer the amount of amps that will be flowing through a bulb if you know the wattage and you know that it hooks up to 120 volts. And back to the original ballast project, a ballast is a type of electrical transformer. And you can see right on here, it takes 120 volts in, which is what you get out of your wall, and it spits out roughly 600 volts. The RMS stands for root mean squared. It's something to do with how the energy is measured, or the voltage is measured, doesn't really matter. And you will find transformers all over the place. That's exactly what these guys do. And you can see it right there. Input, 100 to 240 volts. That's so that it works in Europe. The frequency is basically the rate at which it oscillates. And no matter what you put in, DC voltage comes out at 5 volts. That's why it can't hurt you, 2.1 amps. The last place that you'll find transformers is on the side of telephone poles. I should have looked this up first. Hopefully you'll give me a thumbs down for not having edited this now. But basically on a telephone pole, all of those guys, those are transformers. And they're doing the exact same thing that this is doing, although this is putting out DC, that's still AC. The reason for that is, and this is maybe beyond what I was planning to talk about, but anyway, the reason for that is when the generator at a power plant spits out electricity, they want it to have super high voltage and super low amperage. The reason for that is when you have a super high voltage and a super low amperage, you can move lots of electricity and wattage and energy across relatively thin cables. Whereas if it were the other way around, you'd have to have huge, massive cables, because the cables have to be large enough to dissipate the heat in the circuit, and the heat is largely related to the amperage in the circuit, not the voltage. So don't quote me on this, but the power lines that you see running down freeways and things like that, and across mountainous regions, I think they're in like the 250,000 voltage range. The problem with that is when you have super high voltages, the electricity can arc a huge gap. That's exactly how a spark plug works. And so if you had 250,000 volts here, you would get shocked and electrocuted when you were like 3 feet away from the outlet. It would just jump the gap and you would become the ground and you die. And so the transformers, I don't know exactly what the amperage is. Let's just say it's 1 amp. Don't quote me on that because it's probably not 1 amp. What they do is right before they get to your house, they invert this so that you only get 120 volts and, I don't know, 50 amp circuit or something like that. And they do that so that as you go to plug it in, you don't get zapped. So yeah, I hope that was helpful to somebody. When electricity was demystified for me and I started learning how this thing works, I was super, super excited. I was about 17 years old. I felt like this whole new world that was clouded in mysticism finally made sense to me. And so if I can even play a small part in helping someone get to that point, that excites me, and that's why I want to share this stuff. I'm not trying to position myself as an expert, and you shouldn't listen to my advice and go rewire your house or something like that. But from an educational standpoint, to unlock the mystery of electricity, I'm hopeful that this will help somebody. If not, let me know by giving me a thumbs down. Go over and check out a guy, Steve Mould. I think he's maybe British or something like that. Super interesting. He does stuff about physics, including electricity all the time, and super interesting guy. All right, folks, take care.